viewers to this edition. In this episode, we want to have introduction to the topic probability. We have been using the word probability in various ways or in various contexts. In this episode, we want to deal with the introduction. What is probability? What is the game of chances? Probability simply put us in a layman perspective could be the study of chances or the likelihood that something will happen. There are so many instances where we are faced with chances, we are faced with likelihood of event occurring or may not occur. That is just the probability. The probability that it will rain today. We can have that values being ranging from 0 to 1, whether it may happen, it will not happen. You can see the cloud gathering, becoming darker, then you are convinced to say that it will rain, but you might be surprised at the end of the day there is no rain. That is a chance. It's a likelihood that what you perceive may occur or may not occur. When they come to the scientist aspect, when they draw their hypothesis, they try to see if they can get their findings correlate with what the hypothesis. That is a chance. It's probability. So there are so many instances whereby we can see probability being used in our daily life. For example, let's take a typical example as a lottery number, whereby we choose numbers between 1 and 90. The day you are writing your lotto or you are staking your lotto, you have a conviction that this too sure you have is going to come out when the machine numbers are being mentioned. But at times it happens, at times it doesn't. So it may occur or may not occur. At times when it comes to traffic light, you perceive that today, because of your work schedule, you don't want to spend more than 1 minute or 2 minutes in front of a traffic, or you pray that when you get there, there should be green, but you get there red, you can stay there for a number of hours. It's a chance, probability that you may be able to escape the red light. When it comes to insurance, nobody knows what happened or what life hold. That's why people insure their properties. So if you buy a car, you trust yourself, you are an expert in driving, so you don't need to have an accident, so you don't need insurance. But you don't know what happens. People buy a car a day and the next day they have an accident. So if you have insurance premium, that can cover you. Somebody may buy a car for 15, 20 years, they will have no case of accident, but they will continue to pay that insurance premium. That is what we are calling what? It's a chance. It's a game of chances. Then when it comes to sports, you can see that you either win, lose, or draw. None of those outcomes is certain. Nobody is certain with those outcomes. That is a probability. When it comes to medical field, diagnosis of disease are also done with the same probability sense. You are telling your doctor your stories, your symptoms, then he will marry that story or symptoms with a predestined word, symptoms of a particular disease. Then he can correct, no, because of the way you are coughing, it is not caused by this bacteria, but rather caused by a fungi. It's a chance, probability. So we have so many series of probability around that. You can also add to the list. So today, when it comes to mathematical sense, we will be dealing with some important terms that will come into play when you want to deal with probability. We will be dealing with an experiment. When I talk of experiment, what does it mean? So an experiment is just any action whose outcomes cannot be what? Predicted with certainty. Any action that you are taking whose outcome or result cannot be what? Predicted with certainty. You can't be certain of the result. You are doing an experiment. That is all about mathematics. So we have random experiment. It is also an experiment, but this experiment whose result depends on what? Chance. The result of that experiment depends on chance. Simply put, that you cannot determine or predetermine the outcomes of the result. You are doing random experiment. You are just randomly selecting your actions. That is random experiment. Then we have a trial, which is a single performance of an experiment. If you take a die, Ludo die, and you throw a die or you toss a die, you see that single time that you are throwing that dice is the trial. You are trying. But that trial is also from experiment, because it's an action which you cannot determine what you get with certainty. You may shout 6 Miludu, but you may get 1. Your certainty is not what you get, it's a chance. Then we have what they call event. The event is just possible outcomes of an experiment, or of a trial of an experiment, or possible outcomes and combination of outcomes. So if I take a Ludo, for example, if I throw a Ludo or toss a Ludo, then I have what? 2 appearing. The 2 become the event, that become the possible outcomes of that experiment. If you cast a coin, then you have the head. The head is the event that you have out of the pool of what possible outcomes that become the event. Then we have what they call sample space. Let's just say it is a universal set, the pool from which the event has been selected. So our definition on probability from the beginning was just a layman understanding, which is the study of chances or likelihood of something happening. But mathematically, we can also define probability as the ratio of number of successful outcomes. When you throw a die, what you get is a successful outcome. So it's a ratio of the number of successful outcomes of a random experiment to the number of possible outcomes. Simply put, is a ratio of event to what? Sample space. So we can define probability as event equals to number of events, that is successful what? Outcomes. So we can say number of event over total sample, or total sample space. So if we are going to deal with mathematics, this is going to be our watchmark. Every calculations we are going to do, we are going to mirror it to this mathematical expression. Now, one thing we have to also know is that when we are saying event is likely to happen, it can also happen that it will not happen. So there are 2 things there. It may happen or may not what? Happen. So if I'm tossing a coin and I'm saying that probability of obtaining a head, the probability of obtaining a head is one side of the experiment, and probability of not obtaining the head is another side. So either I get the head to be certain, or I may get the tail not to be certain. So it's either the event occur or the event may not occur. In either case, the 2 come together to form a complete set, meaning the total should be 1. The probability is ranging from 0 to 1 inclusively. Simply put, if I have 0, it should be probability of the event is between 0 and 1. It is inclusive. So if the event is going to occur plus the event may not occur, both should come together to form a whole. So what I mean is that if I have probability of event being occurring plus the probability of the event not occurring, both should be added to give you what? 1. Don't forget, we use the bar to indicate that the probability is not occurring. Then this is occurring. Both should give you what? 1, because the numbers are between 0 and 1. Alright. So in any event, for us to be able to use letters, we use the first letter or convenient letter from the event to represent our set of numbers. Then we can perform our calculation. For example, so we have to find the probability of getting a head by tossing a fair coin once. We are tossing the coins once. You know, when we are playing football, the referee tosses the coins first to determine which team pass the ball, then a toss again to determine which team is going to choose the left or the right side. The first one is ones, so we are referring to that ones. So let's see, we need two things: the event and sample space. So first of all, let S represent, we can say represent what? A set of what? Possible sample space. So it's a set of that. So what are the possible sample space if you toss a coin? We said there are two sides of a coin, the head or what? The tail. So we have head or we have what? Tail. But we need to know number of chances that are there. And there are two chances. So we can say number of S is going to be 2. Don't forget that N here is borrowed from a set of numbers. So number of elements of this set is what? 2. Then we need to go for the event, which is getting ahead. So we can say let A or B equals to a set of what? Obtaining a head. So in that case, A is going to be a set of what? Head. Then what is the number of A? And that is going to be what? 1. So per our definition, probability of the event, which is now A, equals to number of the event over number of what? Sample space. So by substitution, we are going to have 1 out of what? 2. So this simply means that the chance of getting ahead is what? 1 out of 2 is half, meaning 50. Then the chance of not obtaining a head will also be 50. So 50 plus 50 give you 100% chance, which is the 1. So what we are trying to say is that if I want to find the probability of not obtaining a head, meaning I'll be referring to obtaining what? A tail. If I don't get a head, I go for a tail. So the question could also be find the probability of not obtaining a head, which is the same as obtaining a tail, which the answers in each case will be the same. That is probability. So the introduction is just in this video. In the subsequent ones, we begin to take series examples, how we can be able to even toss a coins what? Twice or even thrice. There are so many chances of probability around us. Come with me in this space so that we deal with the topic probability to the end. Thank you so much for watching. If you like this video, don't forget to share with your friends, learning mates, and anybody who may need this video. Thank you. Bye-bye.